Hello, welcome to another edition of Allmech. This one is quite an interesting one. As some of you may or may not know, I have a BMW i3 electric car, and when I had it, around 6 months of driving, no problem. But then the following winter, the car was completely stranded, and it basically left me at -15 on my driveway with no way to even put it in reverse to pull it out the driving space. Result is I ended up getting a tow truck, and I ended up getting it taken to Schematic where I work. And after work, I sat around trying to diagnose what the problem was. No surprise to know that there was a CAN bus failure, PT-CAN, but it was actually PT-CAN 2, which is the backup line, which was very unusual because I thought being a backup line, the PT-CAN was still intact, it would work. But no, it completely shut the car and trashed it completely. And the reason was we had a problem, as you'll see in the video, with the wiring on the vehicle. And it took a hell of a long time to find it. Then I spent several days redesigning the wiring harness completely because it's completely unsuitable for Finnish weather. It runs externally on the left side of the vehicle, outside of the car, away from the carbon core, which is flammable. Basically, carbon, if you have a short electrically, it can set on fire. So they route it outside the car, down the side of the plastics and over the metal subframes, front and back. And the problem is that when you don't have a CAN bus functioning, the messages from all the control units in the car, they can't talk to each other. So basically the car doesn't know what's happening and it just shuts down completely. You can't move the gear stick, can't do anything. All you could do is take the handbrake off. So what we're going to learn in this video, it's going to be quite an interesting one, I think, is you're going to first of all learn about the PT-CAN system on BMW and how it works in relation to PT-CAN 1, all the control units that use this CAN bus, and then you can actually see some with images, not so much videos, because this was the early days when I started doing videos. But you'll see with the images I've taken what the resistance value should be. It should be 60 ohms, but we're going to split the circuit up into different sections because it was really, really difficult to find the break. But I wanted to find exactly where it was because I wanted to know what had gone wrong. I ended up actually replacing 3.5 meters of twisted pair because I just wasn't happy. It was the water had gone so far, 2 meters into the wiring, it was all black completely. Obviously, it had been faulty for quite some time and held a lot of water. It's quite amazing testament to CAN bus actually that it stayed intact for as long as it did. With all that green corrosion, it still managed to get messages through, so it's quite incredible, really. And the moment I found it was brilliant. So let's have a look first at the wiring diagram and give you an idea of how the system works on this car, and then the fault codes, what they were, and then we'll start looking at how it was diagnosed and how to diagnose CAN bus, because it could be quite useful for you if you don't understand CAN bus. You don't understand how to measure resistances and what the resistance values can mean, then this video will absolutely help you. And it doesn't matter if it's BMW or any brand, no matter. You've got a pair of terminating resistors at one end the other end, and if you know how to, what the value should be, you can't go far wrong. So without further ado, let's check out the schematic architecture of the BMW i3. So if we take a look at the CAN layout now on this car, which is the i01, that's the main line, and it has a resistor on the gear stick module and the electrical machine electronics, both of 120 ohms each, and that basically makes a total circuit resistance of 60 ohms, which we'll go through shortly. If you see 120 ohms, you've got a problem basically. So that's the main line, the green and the yellow there. So if we look at this one now, that when I said RT means total circuit resistance. That's basically to shorten it. And if you've got an intact bus, you'll see 60 ohms everywhere on the bus basically. And there's the calculation. So total resistance will be the two resistors, 120 ohms times 120 divided by basically the same again. Add them up, 240 equals a total resistance in that circuit of 60 ohms. And that's Ohm's law, and that's obviously quite important. That's how the system works in parallel. In series, it's a totally different matter. We won't cover that here. The main line, if you get a break on that line, nothing's really going to work. There is an argument that if you've got one part of the main line, either CAN high or CAN low, it will work to some extent, although I've not seen that myself. And on my particular car, the main problem was the line was broken here, the main line, between the electrical machine electronics at the back of the car and to the front of the car where the gear stick module is. And because that was broken, nothing could communicate and the car was basically completely stranded. And that was the problem. And in that case, we had a total resistance of 120 ohms. And as a fault finder, whenever you see 120 ohms, you know you've got a problem with the main line, basically. It's as simple as that. If you don't have a problem with the main line and you have a problem on branch lines, that's a different matter and not quite as catastrophic. Here is an image that I produced for my LinkedIn newsletter over a year ago, so the resolution isn't quite perfect, but it saved me the time of reproducing another diagram. This is quite useful for you. I thought I'd throw it in because it's kind of a CAN bus tutorial, and it shows you the various states what you could have in the bus when you have breaks in the line. So you can actually pause that and go through it yourselves at any time during this video, and you can sort of get an idea of what you would see under certain circumstances. Well, any good story starts on the back of a really nice tow truck, and there's my lovely view from it. And this little resistor, 120 ohms, I've got 2 of them from Partco, really helped me out. And you're going to see in the video exactly just why they're so useful. Not everyone uses them, but I swear by them and I think they're great. So let's go and check it out. So I'm actually on a bit of an holiday from work now, so it makes making parts of this video for the i3 that much easier. One of the reasons why on my videos they're not so polished is because purely and simply I have a job to do and I don't have the time really to take me time, so this is a bit of a pleasure for me really. And of course this video is going to follow on from the very first video I ever made from my YouTube channel, which was absolutely garbage because I was still learning how to make videos. That was like a year ago exactly, February 23. So this is a pleasure. I can take my time in my yard and my house. You can see here the traffic going past there. And what I'm going to do now is I'm going to pull off the rear lid. And by the way, these are a real pain in the arse on the i3 because they're made of rubber. These little fasteners underneath, these threads. And that's why I'm doing it very slowly with a screwdriver, because you use the air tools or my key to drill driver, what I have. You just strip the threads. And nobody carries these in stock. And what I'm doing, I'm just pulling the rear lid off because I think it's really interesting. It's been like a hell of a long time. It's been over a year and a half since I repaired the CAN bus on this car. So I think this could be dead interesting. So let me whip these off now and we'll carry on in a minute. I find it easy on the i3. If you just leave the last 3 input loose, you can just sort of slide it in after. Right, so I've not had this off in God knows how long. It's not looking very clean, is it? Jesus. This is also what I hate. Look at the corrosion. I've put grease on that actually, but look at the state. There's absolutely no protection from nothing. And it's not good, is it? So what I did on the video, you'll see on my pre-recorded stuff from a long time ago, you've got that connector there, and you can barely make it out, but there is actually all the CAN, Flexray and PT-CAN 1, PT-CAN 2 is in that connector there. Connector comes round this way like this, and it ends up going through this sub-harness connector, which is very useful. And the reason this is useful is you can separate the CAN bus into different areas without chopping the wiring. So we can chop that. We can, instead of chopping the wiring, if we had like a short on the CAN, we didn't know where it was, or a break or whatever, we could basically disconnect that there, and then on from there on, we've got a bus that goes down to there. It goes to the battery unit, of course. That sort of snakes back that way, and then it goes that way. You've got the high voltage compressor as well, which goes down there. And as you can see, there's a lot of control units. The Rex would usually sit there, but thank God we don't have a Rex motor, because they're just a waste of time. This is the 120 mine, so it's got a big battery, so it has more range than Rex anyway. You don't need a big Rotax motorcycle engine there, but as you can see, and I'm not very happy about it, there's a lot of wet and water in here. There's no protection lock, and you need that for the air cooling, because it probably does get quite hot when it's on full chat, especially in summer. But I'm thinking I'll make something for winter, because this is ridiculous. Look how much water there is on that. That's just insane, isn't it? So I'm gonna have to go over all this again. But as you can see, that's the area where the brake was. It's pretty difficult to see actually, even in the daylight, and it was just down there, just where it curls over the subframe. And troubleshooting on the video, obviously I was using a resistor at the front, which I'm going to show you in a minute, downstream of the GWS. So all we had was, when this was disconnected, the EDME was disconnected, which I'll show you in a minute where that is, and everything else on the CAN bus was disconnected. We just had a main harness going all the way down here, and then obviously all the way down the vehicle that way and up into the Frunk area, and we were just measuring with a resistor in the Frunk area, which you'll see soon on the video. And then we were measuring sort of from here all the way down there and trying to loop back from the resistor, and we were getting a weird sporadic value. And the reason we were getting that sporadic value is because there's a intermittent break, which you'll see at the end of the video where it was. Unfortunately, I didn't do so many videos. I just did a lot of photos on this repair, so it's going to be video and photos. But there you are, that's the i3, that's my little car, that's how it works. Just a few things I can point out. For example, that's the DC-DC converter, so that obviously powers the main 12 volt system. And obviously that's the ground for the 12 volt system, which goes to all the subframes. You have various grounding points like that one there, for example, and I think there's another set down there, but you can't see them. And obviously that converts hundreds of volts down to 12 volts. So this is the whole thing here is the electrical machine electronics. And that's not only, as I said, responsible for the electrical machine, but it's responsible for, with the electrical machine is the gearbox and motor assembly, which is underneath. And that's not just responsible for powering the car, it's responsible, as I said, it's got a DC-DC converter, and it's got a multitude of other responsibilities also. But the main thing I wanted to show you, which was dead important, was the fact that we can separate the Flexray PT-CAN 1, PT-CAN 2 into different pieces here and also in the Frunk. So let's go and have a look at the Frunk area, say bye-bye to this. And I'm glad I'm not fixing it again, but I'm going to have to do a lot of rust repairing on this. I mean, that's just, it's not looking good, is it? So let's go to the Frunk. So there's a heat pump valve actually. It's quite a nice thing to see. I did a video about that not long back. So here is the two main connectors, which are very, very useful. And over the years of fixing these cars, I can tell you exactly which wiring colour does what. And this is with the starting point, as you'll see in the video soon. This area enables you to disconnect the GWS side, which I'll show you where that is, which comes in here, and then it goes down towards the left side of the car. This is a really useful connector, and I'm just show you what I'm doing at the moment. I'm just pulling away this Frunk area now because I don't have a 10 milli on me, and it's just down there. And those two connectors, you don't always get these on most vehicles. They're dead useful because usually it's just one solid wiring harness. And the reason this is useful, as you'll see pretty shortly, is if you think about the CAN bus in total on this vehicle, if you think about inside there, you've got the gear stick module, GWS, as you saw on the wiring diagram. That's the first terminating resistor. And the last one is sort of way back yonder over there, which is at the EME, electrical machine electronics. So you've got a circuit that goes all the way, literally just down there, from in the car. That's the start of the main line. The main line then goes all the way down there to the EME. That's the main line. Tied into the main line, which is a really wonderful design, and you can't quite see it, under the vehicle here. Sort of around this area was where all the branch lines are actually crimped into one connector. Terrible place to put it. BMW have an habit of doing that. Look at all the grime you've got here. It's absolutely filthy. From that branch line off the main line, remember the main line goes EME to GWS, it goes all the way up here to the EDME, which is just nestled up under there. And the area what I fixed was way behind here. Again, terrible area where all the dirt and grime and crap goes. So you've got your first branch line goes up here, and then bizarrely, this is really weird, I just shut this door. The branch line, took a bit of waste of wiring, EDME, then the next branch line goes all the way along the car here. All the way along the car here, and yeah, believe it or not, it is a branch line, and then it just doubles back on itself. So it's a bit weird, you would expect like it not to do that, but then it comes all the way back here, then you've got one that goes down sort of to the battery there. Then you've got one that comes down to the SME unit. So yeah, it's not a good design really, to be honest. It's absolutely terrible. And that was what I was up against, so I just decided to separate the system into different pieces, and thank God we had all these type of connectors here, and like the one I've just shown you at Frunk. Just go back to Frunk again, see if I can show you a bit more. The EDME, which is actually located inside here, a little tiny control unit, is also a gateway module for the PT-CAN 2. And obviously PT-CAN 1 and everything else goes through the BDC module. So it's a bit of a strange layout really, in my opinion. But yeah, it was really, really useful to have that connector there. Indeed. So let's take a look at what I did from the snapshot of images I've got, and you can see how I solved this problem, which literally left me stranded right here on my driveway, and the truck obviously came down here, which was a nightmare. As you can see, we've got a big hill here, which is a goddamn nightmare. So there you are. So there's the 120 ohms, a bit over that actually, and this is the back of the car measuring the main line at the electrical machine electronics connector. You can just see the Fluke probes there, and this was a good example of why wiggle testing works. As you can see, it's not stable, it's a sporadic break because there was so much corrosion in the wire, as you'll see at the end of the video, or close to the end of the video. And as a fault finder, it can drive you mad, and as a young fault finder, it would probably drive you even more mad because you wouldn't understand why you're suddenly getting a kilo ohm or a mega ohm value, and why you don't just get what they teach you in training college. Oh, you'll have 120 if it have open circuit. Well, not necessarily. If it's open circuit, you will, but if it's a corroded open circuit that makes and breaks, you won't. So the GWS is there. That's the second resistor, as I've just shown you. The first one is in the EME. This is the main line, of course, as you saw on the first diagram. And any branch line off that, if you have 120, all your branch lines have got 120. So nothing can talk to each other because the signals just won't work. In this case, it was more dangerous than that because the signal couldn't get through at all, because obviously the corrosion was so great. So the area where the break was, you see in more detail shortly, was kind of around the back subframe. At this point, I hadn't found the actual break. I just found roughly the area, and it was around 30 to 40 centimetres from the area I was just wiggling in. So the benefit of going to this connector here, the EME, and disconnecting it at the front of the car is you just got one line all the way down here now from the EME, goes all the way down there, down the side of the vehicle, and you can just see the connector for the EDME hanging out, that's disconnected. And I've even disconnected the GWS from here because there's no point messing around checking 3 meters of wiring into the vehicle when all I need to do is go to this loop here. So I put in place of the GWS a 120 ohm resistor, which was really crazy useful because now I'm able to bypass the GWS side, because look, you don't want to be testing wiring unnecessarily, right? So I'm simulating a GWS by doing that, go to the EME at the back, and then eventually when it's fixed, I should have a stable 120 ohm while I'm wiggling the harness. Then I can plug it back in, plug my EME in, and I should have 60 ohms wherever I measure it and backpin it anywhere on the circuit, whether that be the EDME, the EME itself, or any other such ancillary, even the high voltage battery, for example, SME, all those type of things we saw in the diagram. You should get 60 ohms when the circuit is fixed. Oh, this is the connector for the GWS, which is down there, and according to the wiring diagram, in fact, there's the two CAN wires there, which I've been probing. These two, it's blue and yellow. Sorry, blue and white and yellow and white. And that's where one terminating resistor lives, inside that unit. Now, to take that unit off here is a bit difficult, so I would recommend that you just drop the lower shroud. There's two Torx 30s here, one there, and then there's like one on that side, and then you can drop it down, then you can get a little tiny screwdriver from underneath to push this connector, because it's got a spring there and a spring there, and you've got to push them at the same time. So you gently get from the bottom, like under there, with the shroud off, it's the easiest way. Then that's one way of measuring the overall resistance, but you can do it anywhere. You can measure resistance, like I say, at the EDME, which is just down there. So although we have those nice connectors, what we can disconnect and separate it in half from the Frunk to the EME part, unfortunately, I still couldn't find where this brake was. Bearing in mind it's all taped up, it could be anywhere along that 4 metre line from front to back. So I decided to undo the tape in the bottom left corner of the front of the car, and then I chopped the main line once I'd identified it, and then I put in a resistor there, and then I run about 4 metre long Fluke extension cables from the EME basically. So all you've got is the main line cut in half and the EME disconnected. So it's just a bare wire to the EME, and obviously on top of that you have no branch lines because I've disconnected all the branch lines, because that's where the branch line point was. And as you can see, I've got a really, really weird value there, I think of 11.86 ohms, which is really weird considering I'm trying to measure a connector of 120. So what actually happened was, in the end, obviously, as we saw in the previous video, we had a corrosion at the back, but it was so sporadic, it was playing merry hell with everything. There was just no way to do anything. So at that point, I just thought, sod it. I'll just rip the whole harness apart, take the tape off everywhere, and I'm going to find this brake. I knew there was a brake somewhere at the back, but obviously at the front of the car, that's not really so well protected anyway. I did measure from that point on the other side, not that wire there, but the other side of the wire, what I'd cut in half, back to the GWS, and I got 120 there into the GWS with the connector connecting. So I knew from front left wheel up to the inside the cockpit, everything was perfect. So it was between this point, front left wheel, and it was between the EME, and that was it. So let's go and have a look at the state of the harness and have some fun. So here's a little teaser of the rear subframe area. That's where I found the problem area, which was a moment of celebration, I can promise, because it was after work. It was about 8 o'clock at night. I just wanted to go home in one of the courtesy cars from work and then come back and do it the night after. But let's just turn our attention first, tease you a little bit, back to the front subframe area and just show you how, in my opinion, how poor the wiring harness protection is from BMW. You can see the PT-CAN 2, you can see where I was probing there. That was actually prior to me cutting it and putting a resistor on to separate the circuit back towards the back of the vehicle. And obviously, you know, that was the area where the fault was. And you can see there's the PT-CAN 2 again there, and you can see PT-CAN 1 is kind of nestled in a bit there as well. I think that could be the PT-CAN 1, the blue and the red one there, what's twisted together. That's PT-CAN 1. And then somewhere along there, there'll be Flexray as well. So all of the safety critical parts of the vehicle, I think the pink and green is Flexray. Everything is intertwined. Outside of the car, there's the Flexray there, pink and green. So everything on that vehicle is just literally sat outside in all this Finnish winter disgraceful weather what we have, basically. So it's pretty hard to believe that, isn't it? But that was one of the reasons why I had the issue in the first place. There's the PT-CAN crimped per, which is a bit like the PT-CAN 2 crimped per. And you can just see exactly, like, why would you put crimped pers to branch lines and main lines on both safety systems under the vehicle? It beggars belief. But, you know, that's how it is. That's how they design things, and that's why I had the problem in the first place. And this area at the front is actually the area where the fault usually occurs, which is why I went there, because someone at BMW told me to go there. So let's take a look at the Eureka moment. And in the end, the moment we've all been waiting for, at the rear subframe, where I showed you a few minutes ago the wiggle test, we found a really bad looking harness once I untaped 3.5 meters. And it didn't look so clever, and I thought, aye, well, this is definitely PT-CAN 2, yellow, white, yellow, blue. Let's open it up a bit. Put a little screwdriver in, and lo and behold, boom, came out right in my hands. That was the brake, and it had literally already been cut, and it was literally 2 halves, just literally not even touching, just basically touching with the force of friction only, and messages were still getting through with that until it finally severed. So that was the brake, that was the issue. Now it just came to taping it up properly. Well, not the easiest image to see, but you can see I've got a new twisted per there, and I did this just to test it. Obviously, cut out the brake until on the right side, back towards the EME where there was no corrosion. Lovely clean copper. And then basically, I disregarded 3.5 meters up to the GWS connector and used green, white, and blue, white. I think it's an airbag one, but it's still perfectly good twisted per. And obviously, you can see there's a small branch line leading off that as well. So it was quite complicated, really, because you've got branch lines all over the shot. I think that was the SME branch line. It's just a very bad system the way they did it. It gave me a right headache. It ended up with like 6 or 7 or 8 lots of wires, all the same colour, and to work out which were which was quite tremendously difficult. So that was what I did just to get rid of that 3.5 meters from rear to front of skanky wiring, and then I built it all up temporarily, just twisted it without even soldering or anything, and I had 60 ohms everywhere where I needed to have 60 ohms. Then it was just a case of whacking it all together and making it good. So let's take a look at that and see how I made it good. So a bit of BG spray wax to finish the installation off once all the wiring was crimped and put into place and soldered, etc. I did actually use heat sheet shrink crimps on the CAN branch lines and on the main line because I prefer it to solder. There's a bit less resistance. But I've soldered CAN lines before, and they've never come back. I've never had a problem with it, but you are supposed to crimp them. Some silicone bead in there just to stop the water running behind the conduit. Not a great design, but you've got to kind of work with what you have. I don't have a 3D printer, otherwise I would have completely redesigned that, I can promise you that much. So everything's all looking pretty good there now. Behind that thick tape, and believe me, there's a lot of tape on there, I can promise you.
We have a abrasion resistant wrap, and of course normal fleece tape because it's nice and soft, and then to finish just some Nitto tape because it's kind of water resistant. And that's the area of the brake there, basically, just where that coolant pipe is, pretty much above the water pump. That's where the CAN line was broken, so it's a horrible area. Having to thread the harness back in. The harness was considerably thicker once I'd armour proofed everything. And it was a bit of a challenge. That was the most difficult area. The front wasn't so bad, but the back was very difficult. Looping it around everything and getting it to fit on its original mounting points where the 10mm headed plastic nuts are to bolt it to the subframe. Very difficult, actually, and i3 is the only car I know of where the main vehicle harness runs externally, as I said at the start of the video, for obvious reasons. And at the end of the video, what I will show you is when I was at BMW training, when we set on fire a piece of carbon by just putting a battery charger through it, and it set on fire in about 5 seconds. So I'll put that on at the end and give you something quite nice to see. So, pretty much that's it. There's a view, of course, of the wrap, what I put on, just so you know how well protected the harness is and how well it's going to be protected into the future. And I will leave you with this lovely image. I wish I'd have took a video. I don't know why I didn't, but there's a lovely image of what happens to carbon core when you put a positive and negative current through it. Thank you very much, everyone, for watching, and I hope you'll watch again.